Hello, physics. The question is very difficult but interesting. The question is: a liquid is poured into a cylinder of mass capital M and height is capital H. This is a cylinder of metal cylinder of uh, mass capital M and its height is H, in which the liquid is poured and liquid its height is small x. The linear density of the liquid is a ratio of its mass of the liquid to the liquid height. So, so the density is d. So d is equal to mass over x. So how much is the mass over x? So what is the height or height x for which the common center of gravity of the liquid and the vessel is in the lowest position? So we have to find the lowest position. What should be the height of x? So what should be the height of x? So where the center of gravity is the lowest. So center of gravity or lowest common center of gravity we have to find. Suppose this is a container. It has h height and h by 2 by the symmetry is a COG. Similarly, if we think this is a liquid and it has x height, x over 2 will be from the symmetry. It is a center of gravity of the common. Uh, so we have to find hc, which is a common center of gravity. So the formula, so hc of common m plus m capital plus m small is equal to m h over 2 plus m small x over 2, equation 1. There's a linear density is given. Density of the liquid m over x is equal to d is equal to mx. So m is equal to uh, dx. So m is equal to dx. So dx. So we will substitute this value of from this one hc. So this will be hc. So mh, wherever this small m is, we will put this one dx. So it will be mh plus x is dx. So dx square. So instead of m. So similarly this one. So this will be m dx into half. This is equation number 2. Now we have to find the lowest position. So that means we have to differentiate with this hc with respect to x. So for lowest center of gravity, we have to differentiate equation number 2. So we have differentiation in this one u and v, numerator and denominator. So dhc over dx for derivative with respect to x, or equation number 2, we have to use the formula uv whole derivative, which is u derivative v minus u v derivative over v square. And for this one, we have to use derivative of u. U is the first one. This is constant. So this, the first derivative. So we will use the equation number 2 for the derivative. For the derivative, so this will be the derivative of this one. So this is u and this is v. This is constant. This will be 2x d 2 dx into v. V is this one minus minus u. This is u into derivative of this one, which is d, which is this one, into d square. So which is equal to 0, which is the condition for, then we will use this one, 2 dx m plus dx minus mh plus dx square into d is equal to 0. Simplify this one with respect to the variable is x square. So this is uh, 2, this one, and 2, this one, and this one. And then we will have 2 and minus 1. So that will be equal to d square x square plus 2 dmx minus mhd is equal to 0. Equation number 3. This is a quadratic equation with respect in variable x. So its solution will be x, the roots x, which is equal to minus b, minus of this one, b, uh, plus minus b squared, 4d square m square. So 4d square minus 4ac, minus this is plus 4ac. So this will be multiplied d cube mh4 square root over 2a, 2d square, 2, 2d square. So if you take uh, 2d common from this one, and then we can cancel this one, and then we will have this formula, which is x is equal to minus, so that will be better to write is in this form, which is equal to minus md plus minus m squared d squared plus mh over d whole square root. This is the root. Uh, so this is the roots, two roots. We will only take a positive root for its positive meaning. There will be other root which is a negative. The positive factor has a physical meaning of x, this is the height. Negative high x is, we will not use it. So we will use only the positive one, this one. So the positive minus x in this one. So this condition, here we have to focus on this one. So if this one mh, so okay, so the positive one, so this is x become positive. So now we consider this one. I make it slightly brighter. Okay, now if we consider this one, start from this one, this is the root of this equation, which is equal to x m uh, m over d plus minus m square d square plus mhd over square root. So we will take only positive x. If you consider this negative, this will be negative. Negative x is not meaningful, so positive factor. So we will take only positive factor. So it has a physical meaning of x. X is the height. So if this is equal to uh, the common LOC, center of gravity, COG. So this is m over d plus m square plus d square plus mh over d. So now we will take the condition that mh is equal to, so dh is equal to m. Density and height is equal to the density of the liquid, and multiplied by height is equal to the mass of the metal of the vessel. So this one, so mh over d, so uh, m over d, m over d is equal to h. So if we put this one, so this will be h square plus h square. So this is equal to minus h minus h. So minus h plus h into and square root 2. So that will be equal to x is equal to, so this x is equal to 41% of h. So the x, the center of the for uh, the value of x for which center of gravity will be the minimum is 41%. X should be 41% of the height of the vessel. If the d multiplied by density multiplied by the height is equal to the vessel mass. Condition 2, dh is less than m. If it is less than 1, then this equation, from this one we will have this equation we will use, no, this is x. So this x, which we have this one, this x will be modified by using m over d common, and taking this m over d whole common. So this will be m over d into this minus 1 plus this 1 plus hd over m whole square root. So from here we will use the series expansion. So 1 plus x raised power 1 by 2 is equal to 1 plus x by 2 plus so on. So if we do this one, so then it will be equal to plus minus 1 plus 1 plus dmh into 2 minus d square h square over 8m square plus so on. This will be a series expansion. So if you uh, simplify this one, so this is minus 1, this is plus 1, this is dh over 2m, and this is square term, this is cancelled. So if you multiply this one, so this will be multiplied by this and this. So this will be m cancel, d h over 2, d cancel, so h over 2 minus d h over 8m, h over 2 common, so that will be equal to uh, this expression. So h is equal, x is equal to h by 2, 1 minus dh by 4m. So x is dh over m from this one. So dh over m is less than 1, is greater than 1. dh over m, dh over m is, so the dh over m from this one, dh over m is less than 1. So dh over m is less than 1. dh over 4m is further less than 1. So this is less than 1. So this will be h. This will be h is lower than, x is below middle of the h. if this condition is followed, that the vessel is equal to the mass of this one. Number third, it is third is D. Second is this one. Second is DH is smaller than. Next one is DH is greater than M. If it is greater than M, then X, this will be X is equal to M square D square plus MHD minus M over D. Take H out. If you take H out, so this will be M square by D H square D square plus M HD minus M over HD. So from here, we can see this one. It is a similar pattern. M over HD, M over HD, M over HD whole square. So M over DH is greater than this one. So if it is greater than this one, so this will be H. X is equal to H and square root of this one. So this is well above the H. So this is so uh, x is less than h by 2, and it is also uh, h is less than half of this one, and h is less than half of the 2. So this is a slightly complicated and difficult answer question, and it need thorough calculations.